Right. So today we want to start our next subject also, that is emerging technologies in IT. Okay. So far we have start discussing quality assurance. Uh, then we have start discussing e-business, uh, and also we have start discussing mobile application development and network security and audits. So today we want to start the topic one and possibly finish also, hopefully, emerging topics in IT. So remember, this is EN subject. EN subject means you know what is EN subjects are. You need to pass it, but you don't get ABC, right? But you need to pass it. If you fail, so that doesn't complete your degree program. Okay, right. So this subject is heavily technical, right? In a way, heavily technical, but some theoretical as well. The most technical topic is uh, topic one. Okay. So basically, the topic one is the most technical. Other topics are technical anyway, like even something like data science and so on. Yes, second topic is also fairly technical, we will say. Uh, but other topics we look at mostly the theory part. Okay, those are very technical subject, but we look at the theory parts. So therefore, this subject is very challenging, extremely challenging. Okay. So therefore, you must be very, very serious. Just like mobile application development. Remember, mobile application development is very technical topic. Especially these first two subject topics, because you need to have some hands-on experience, some serious hands-on experience if you want to understand the concept. But in the exams in last 3 years, examiner has not checked your practical skills. Examiner has checked only the theoretical things, but that is for last three papers. But we never know in your paper. Sometimes examiner might go into practical aspects. Okay, and whether examiner go for the practical aspects or not, it's always good to know these things because these are the essential skills for us IT professionals. Essential, must have. Okay. Right. So let me show you the syllabus first. Emerging technologies or emerging topics in IT. Right. So this is the syllabus. It's a EN subject, right? 2 credits, but not GPA credits. Okay. You can see 15 hours theory, 30 hours practical. So twice for the practical. Okay. So just keep that in. And also 55 hours independent learning. Right? Independent. That means you need to do a lot of self-learning. Explore these topics because these are the emerging topics. So you can see 15 hours of theory, 55 hours of independent learning. So it shows how much of a responsibility is coming to your side. Okay. So this is not usually the case in other topics. Right. So the course aim, this module will provide an overview of some of the emerging information technology topics or technologies. So intended learning outcomes, identify the range of disciplines to which IT is applicable, develop new skills related to topics covered in this module or this subject, like AI and so on, apply newly learned skills and develop IT applications related to these topics. So can you use these technologies in your applications? Right. So you have 6 topics: microservices, data science with Python, AI, social network analysis, digital forensics, extended reality. Okay. Right. So these three are the more time consuming topics. The last three we can do quickly. Okay. So therefore, we need to take a little bit of time for the first three, but the last three we can do faster, especially the last two, pretty much theory. Pretty much theory. Okay. Right. So today, now these topics are not sort of this subject is different because these are sort of different topics, emerging topics. Okay. You can see. So these are different topics. There's no flow of after first topic you go to second. We can do any topic at any order. Okay, right. But only thing is the social network analysis. There's a connection to artificial intelligence, and of course these three have a little bit of a common things. Right. So we'll start with microservices. Microservices. Uh, Again, for this subject also, at the end of each subject, we will do the papers. So therefore, and you have only MCQs for this subject. You don't have essay paper. So therefore, at the end, all the past papers will be done. That means there's nothing called past paper discussion at the end. Okay. For each and every topic, we do the past papers. So last 3 years of past papers. Right. So microservices. The monolithic system, service-oriented architecture, introduction to microservices, key benefits and challenges, design patterns. Right? Practical, simple microservice application using Spring Boot. Okay. Right. For this topic, I have enabled, uh, I have not prepared our own note, but I have highlighted your note so that you can understand it better. At the same time, I have given you 2 practical sheets, and the UCSC also has provided another practical sheet. So you have 3 practical sheets for your independence learning plus practicals. Okay. Right. Microservices. Uh, so this is the UCSC note. These are our practical sheets. This is the UCSC practical sheet. And also I have given you 3 references, YouTube videos. I will add few more references, YouTube videos before the next class. Okay, few more. Those things you need to visit if you really want to get the practical understanding. Of course, just going through this UCSC note, you will be able to answer almost all the questions they have asked so far. But remember, the exams and your degree is short term. Your confidence understanding is long term. For example, if I am going to be in the IT field, maybe that understanding confidence is for another 40, at least for another 40 years. Okay. So therefore take this very serious, especially if you want to go into the IT field. I don't know that some students, maybe they have other ideas. Okay. Right. So first we will go through your UCSC note. Um, and then we'll do the past papers also because all the past papers you can do without practical knowledge. Okay. So then we'll do the practicals, some practical aspects. Okay. Right. So these notes are available in Google Classroom, the highlighted version. right? Microservices. Now you need to be very, very serious, right? Very serious, especially for this topic, and that means this subject. And you need to do a lot of independent learning. So I'm just giving you the big picture, starting, but you need to continue that learning if you want to get into IT field. Okay, right? Because these are the hot areas in IT these days. Right? For example, microservices. So if you don't know about microservices, right? So almost no IT job will be available to you. Okay? And the related things like deployment options and so on. Right. So let's start. So same for the other topics as well. Data science. Those are the areas the next wave of job opportunities are. Okay. Because now the software development jobs are getting lesser because AI can generate the code. I'm not saying that the software engineering field is dead. Software development field is a big field. That field will be there and it will keep continue and grow. Uh, but more and more AI agents will start developing systems, whereas software engineers will just do the designing part, supervising part. So therefore, extremely talented, right? So the best of the best people will be able to remain in the IT field, software development field, the best people, right? Having the serious attitude and so on. But at the same time, there are new job opportunities emerging. Data science, AI, these microservices and deployment, DevOps. These things are also now getting little bit automated. But that gap can be filled by IT students go into these areas, especially AI, machine learning, data science, and so on. Okay. Right. So what is a microservice? So when we develop systems, we use architectures. Right? We use architectures. So remember, if you want to be engineer, right? Engineer, true engineer, your main task is design and develop systems, especially design. Right? For example, civil engineers design buildings, bridges, dams. So they don't build, right? Building is done by workers. Same for electrical engineers. They design power plants, power distribution systems. So they don't go and work on, right, building those things or involved in distributing power. So they do the design part. Same for mechanical, electronic, computer engineers. So far, what happened in software development field is engineers used to not only design but develop, debug, okay, test. Everything was done by engineers because there was no other option and it was so complicated. Right? So that is why we needed few number of civil engineers for very big project, very building construction, maybe just three civil engineers. Okay, for a power plant, maybe we just need three, four, or maximum. Of course, designing and phase you need at least 10, 15. But you know that in Sri Lanka, our electrical engineers never design a power plant. So all these turbines and everything, those are designed in countries like UK, USA, German, and we just take them and install. So therefore, actually, our engineers very hardly doing engineering work, especially electrical engineers, electronic engineers in Sri Lanka. It is civil engineers. Some civil engineers do really their profession, designing. Okay, and of course, so far it is IT software engineers. They did the engineering job because we develop things from grounds up. Not only engineers work, the work of a worker, right? Fixing bug, developing UI. Actually, that is not engineers' work. But we used to do those things because we had no other option, and others can't come and do those things because those are so complicated. But in the future, engineers, software engineers will focus on designing and supervising, just like civil engineers used to do for last hundreds of years and right now. So likewise, software engineers are also going to play that role in the future, right? That senior role. So therefore, now you must be very serious about design, architecture, rather than thinking about fixing small bugs, developing a UI form. Of course, it does. Of course, you need to know, right? Knowing is one thing, doing is another thing, right? So in the future, you just want to know these things rather than do those things. What you really do is very high level architecture design. Okay. Right. So therefore, every software has architecture, design. So remember, we have something called standalone applications like Microsoft Word, or you develop an application using Java Swing, .NET, C Sharp. So everything is in one machine, right? Your database is also in that machine. Application logic UI, you can install it. For example, Photoshop, Microsoft Word, or even a simple student management system, inventory management system for a very like a pharmacy or something. Just one or two people using it, only one branch. So that is for standalone application, simplest sort of application. Even application like a simple calculator, right? So for example, Windows has a calculator, right? It's simple application, right? You just install and use it, right? Standalone architecture. So then we have the network related application architectures, client server, peer to peer. So those are more sophisticated. In client server, you have the server machine, and in the network, clients can access. So clients can request and consume, server need to respond. And for scalability, when we have more and more requests from clients, or more and more clients, we can even go for distributed client server. Different servers located different part of the world, and they get synchronized. So those are architectures. Then of course the peer-to-peer architecture, where there's no single role called client or server. Every machine can request and consume as well as response. So, so standalone architecture, client server architecture, peer-to-peer architecture. Client server also in enterprise application development in semester 4, you learn two-tier architecture, where the web and application both in the same server, like simple PHP application, or three-tier architecture, where web tier is separated from application logic, like JSP servlet for the web tier, and enterprise Java beans for the app tier, right? Remember, you have done these things even in practical level. So likewise, there are so many architectures, right? So many architectures. And also we discuss about web services for system to system integration, right? So therefore, you have that background now, both theoretical and technical. right? We even build some enterprise Java beans, exposing web services in semester 4, right? So monolithic architecture means you develop the system as a one big chunk, one big monster, right? So usually we do that in standalone application because anyway you can develop it like that. You can do it in client server as well. Your server is a big monster, big, right? It's not broken into components. So different logics, right, mix with each other. So that is called monolithic architecture. Like all days television sets, right? Even today's television sets, analog. All days vehicles, monolithic architecture. Everything is interconnected, very complicated. Right? So software also we used to develop like that. Even today, if the design developer is not very good, the designer has very little understanding about these concepts, he or she may also develop like a monolithic architecture. Everything mixed together. That is very bad architecture. Very bad architecture. Maintenance wise, reusability wise, okay, performance wise, troubleshooting. So these are the bad designs. Okay. So all functionalities are implemented, deployed into single software application. Everything is just one software bundle. Okay. So then software developers identify the importance of designing and developing your system as set of components that communicate and collaborate, right, as required. So that is not monolithic. Then it's component-based architecture. Just like you compute as a hardware, you have the SSD separately, RAM separated, monitor separated, processor separated, processor also ALU is separated from control unit, ROM is separated, and motherboard coordinate all these components to communicate and collaborate. So, so when it comes to component-based architectures, it is not monolithic because components have well-defined interfaces and they communicate and collaborate using well-defined interfaces. Okay. So early days of components were web services or something like enterprise Java beans, right? So we call it service-oriented architecture. But those components were big, right? Those components were big components, fairly big components. Okay. Big services. Now you can understand our topic, right? Microservices means what? Not big services, right? Not small number of big services. So big components, rather the new trend is develop software as large number of small services or microservices. So we moved from monolithic architecture to component based, but coarse grained. Coarse grained means big components like web services, service oriented architecture. From that, now we are moving towards microservices. So this is an example of sometimes we can consider web services or the big components. Or service-oriented architecture is also a little bit in between monolithic and microservices. Or it has some features of monolithic. Okay, but in reality, it is monolithic to SOA or the web services because it's coarse grain, big components to microservices. Okay. So in monolithic architecture, you can see everything is mixed together, right? Inventory, shopping, store, right? Sometimes they are separated, but coarse grain. Lot of functionalities in one component. Okay, right? So if it is pure monolithic, everything is developed as one unit, and that unit has all the things. And of course, that is unnecessarily complex because everything is in one software. And deploy is also very complex because you deploy everything together. And scaling is also very difficult because these are too complex. Scaling means when we have more and more users, right? Thousands, millions, right? When your software is one big chunk, it's very difficult to distribute it, load balance it. And also there are issues with reliability because I these if it is down, your entire system is down because it's not component wise. It's not just a component is down. No, if it is down, it is down and difficult to scale, distribute, and also hard to innovate. It's difficult to do new things because this is a very complicated chunk of software now. We need to tackle these complexities rather than thinking of new improvements. So likewise, monolithic architecture is a very bad architecture, right? Not a modern architecture. Okay? But when it comes to microservices, right, so that is the next. So remember, in reality, it is monolithic to component based, but in your node, they consider both monolithic and big components as monolithic. Okay. But microservices is you develop the system as set of small components, like large number of small components rather than few number of big components, just two, three. So those big components again having multiple functionalities. But now the trend is develop it as large number of small services, right? So another name for small service is microservice. Again, small service means that service concentrate on only one task or few very highly related tasks. Okay. In other words, we call that fine grain. So you must familiar with these words, right? Service oriented architecture or the web services are coarse grain. coarse grain. ඒවා නිකන් ගඩොල් වගේ, කබොක් වගේ. මේවා නිකන් වැලි කැට වගේ, බොරළු වගේ. Fine grain and independent services. So there are two things. One is these components are small, that is concentrating on just one small functionality, each component. And these are independent. So in component based, so SOA, those components are somewhat interdependent, like common database and so on. But now they have their own databases and so on as well. So there are two things you need to understand. One is components are fine grained in microservices, small services. Just concentrate on one functionality. Second one is these small services are getting more and more independent. So they have their own database and so on. It's very independent. One microservice is extremely independent from another microservice. Okay. Development, deployment. Okay. So this is the new trend, the modern trend. Go for microservices as much as possible. Okay. Right now you can see large number of small services or large number of microservices, which are fully independent. So therefore, it's fine grain, not coarse grain, like this. So you can see these are component, but mostly they are deployed together, maybe deployed in the same application server. But here you can see large number of components, and these are completely independent. Completely independent. So these diagrams you need to pay a lot of attention. Okay. Right. So when it comes to designing this application using microservices approach, right? So remember the idea is make each microservice concentrate on well-defined tasks or well-defined functionality and make it independent, right? Make it independent as much as possible, right? So therefore, it is not determined by number of lines in the code. No. Say after particular component has more than 1,000 lines, you break it to another. No, don't think like that. Your microservice must concentrate on one well-defined work functionality. It's not the size of the code or whatever, or the team size. No, nothing. Okay. And also, very importantly, microservice must be independent. Right? Independently deployable, design, develop. These microservices can use different technologies. One microservice use Java, other one Python, other microservice use .NET, and still these microservices can work together to build your application. Right. So remember, microservice must have a single responsibility. So each microservice must concentrate on one functionality, not too much, too many things. Right. So you need to find out the service boundaries, business capabilities for a particular microservice. And it must not be too general. And make sure those are agile or independent to develop, deploy. Right? It's mainly the scope, right? Not the size, line of codes, it's scope. Each microservice must do one well-defined functionality. Okay. So you can see one microservice is going to do very few operations or functionalities. And it's going to use simple message formats. Okay. So I remember we are moving towards simplifying things, right? Not complicating things. So one way of simplifying things is, of course, your system is complex. Your businesses are going to be more and more complex. But how do we tackle that? We break it into very small, simple microservices that communicate and collaborate. So microservice architecture is simple, lightweight, right? And of course, independent messaging mechanisms. So messaging mechanisms are to communicate one microservice with the other. Right. So when it comes to messaging means one microservice communicating with the other microservice. Okay. So X microservice need to communicate with Y microservice, get something done. So that result is required for the X microservice to proceed with its functionality. Maybe then it's again need to call another microservice. So that is done through messaging. Okay, messaging. Right. So there are two type of messages in microservices. It's not only in microservices, even in monolithic core. web services. But especially in microservices, what are those two types? Synchronous messaging and asynchronous messaging. So this is not a new thing to you, right? For example, in semester one programming, when you when a method call another method, it's synchronous. So until that method returns, the calling method can't proceed. You are blocked, right? For example, X method call Y method. Y method call Z. So then Z returns, then we got the control back to Y, and then Y can return, and we got the control back to X. Maybe then X call W and come back. So those are now when Z is getting executed, Y is waiting, X is waiting. Y is waiting for Z to return, and X is waiting for Y to return. And then X is waiting for W to return. So that means it's that means it's asynchronous. Sorry, synchronous. Right? Synchronous. Wait till it get the response. It caller wait for the callee to response. Say X call Y, X is waiting for Y to give the response so that X can proceed. So that is called synchronous message. That is our normal approach. Whether it's Java or C or Python, a method calling another method, or one object calling a behavior of another object. So that is also synchronous. Right? So object A create a object B and call the behavior. So then until object, that is why we draw the sequence diagrams. Right? Communication diagram. Right. So in order to synchronous messaging, that is you wait for the response. In microservices, you can use either REST or there's another technology called Thrift. So these are the questions from the examiner, right? What are the messaging communication protocols for synchronous messaging in microservices? What are the two technologies? REST, Thrift. So REST you learn in semester 4, right? Because we discussed REST, right? We discussed both SOAP and REST, but mostly we discussed REST. RESTful services. It's like HTTP code. So you know these technologies now, right? So that, but those are for what? Synchronous message. That means you call it and wait for the response. Then only you proceed with your one. Okay. If one microservice want to communicate with the other Microsoft synchronously, you can do it as a REST API call or REST microservice call. But if it is asynchronous means you call it, say X call Y, but X is not waiting for Y to return. X continue its work, right? And later, yes, Y will give you the response. So X is not interested about the response. There are two possibilities in asynchronous messaging. One possibility, when X call Y asynchronously, either X is not interested about the response or it can get the response. It is not waiting for the response. It can proceed with the work. At the same time, when it get the response, it can process also at any time while you're proceeding somewhere here. Right? So you can say client doesn't expect response immediately or not accept a response at all. Either you don't accept a response or you're not waiting for the response. Right? You continue your rest of the stuff, and when you get the response, you process that also. For that kind of calls in microservices, we can't use REST, but we can use something like AMQP, STOMP, MQTT. So you need to remember these technologies. Okay. So the message formats are mainly JSON, XML, Thrift, Proto, Buff, Avro. These are very specific technologies. I forget to mention here it is REST, normal HTTP request and response. Okay. Normal HTTP request and response. If there's another one called SOAP, then it is XML format. But in asynchronous, it's again you can use XML. At the same time, you can use JSON, Thrift, Protobuf, Avro, and so on. These are the message formats. These are the technologies. Okay. Synchronous, asynchronous. Remember, we even discussed Ajax in web development. That is also asynchronous. But okay. But Ajax is not a microservice. It's normal web response, request response, right? These are between microservices, synchronously, asynchronously, how to communicate. What are the technologies? What are the message formats? Right, so our next subtopic is, now remember, one microservice may need to call another microservice synchronously or asynchronously, okay? Because that response is required, that result is required. Sometimes you wait for that response, sometimes you call it and you proceed with your task. And when you get the response, you process that also. And maybe then you need to call another microservice. And that microservice need to call another microservice. Likewise, there can be a lot of interactions. Right? So how to do those interactions? So now we are going to look at some patterns of how these microservices can communicate with other microservices. Because one microservices can't do everything. Especially when one microservice is just concentrating on one well-defined task. Okay, right. So when it comes to service-oriented architecture or the web services, that is REST web services, SOAP web services, the coarse grain, big web services, not microservices. So we use ESBs, Enterprise Service Bus. So that means these big web services communicating with ESB. Right? So the ESB does the orchestration. Okay. Just give me 1 minute. I want to plug in my power adapter. Sorry for that. Right. So in one approach was these, especially the SOA or the web services, not the microservices, communicating with the ESB and enterprise service bus does the mediation, right? Like message queuing and so on. Even then we can do asynchronous because you just send the message to the ESB and you concentrate on your work, and ESB will send the message to the relevant web service and get the response. And when you get the response, you can send it back. Or it can call it synchronously and get it back. But anyway, the ESB is going to do the coordination. So that is one approach. The same approach we can use for microservices as well as inter-service communication. Your microservice send the message to the ESB. ESB send it to the relevant microservice and get the response and send it synchronously or asynchronously. Okay. But there are some even better approaches these days for microservices, like smart endpoints, dump pipes, and so on. Okay. Right. So let's look at some of these approaches. Right. So now we look at integrating microservices. So the main approaches are These are past paper questions as well. Point-to-point style, API gateway styles, message broker style. Okay. What are the three approaches? Because ESB is considered more as an outdated approach. Uh, or for the SOA or web service means not the microservice. So early days web service, then microservice. So ESB is usually considered as a web service level communication, inter-service communication. But when it comes to microservices, what are the three technologies? Point-to-point style, API gateway styles, message broker style. Anyway, message broker style is pretty much like enterprise service B. Uh, sorry, uh, enterprise service bus. Okay. Right. So let's take one by one. Point-to-point style. Point-to-point style means your client call the microservice. Right? Just call the microservice, and these microservices also can directly call other microservices. That is why it's a point to point, like peer to peer. Because every microservice, say it's a REST, exposed as a REST API. So then a particular microservice can call another microservice, or your client can also call different microservices. So you can see there is no other mechanism. Okay? Point to point. So this is a client point. These are the web service point, microservice points. So another approach is API gateway styles. Okay. In API gateway styles, we have API gateway. All the communication that is client to microservice or microservice to microservice happen through API gateway. So API gateway is the sort of the communication control center. So therefore, this is different from point to point style, because in point to point style there is no such controlling, but here we have controlling. All the microservice calls must be done through API gateway. So it's sort of a central control where you can apply security and other things here. Okay. Right. So third approach is for integrating microservices, message broker style. Right. So message broker style. So that means you can publish and there are subscribe. So microservice can be a publisher or subscriber or both. You can see this microservice is subscribed by this. At the same time, it has published. So that means this is called by store microservice. Accounting microservice is called by store microservice. At the same time, account microservice called the inventory microservice. But not directly. If it is directly, it is point to point. So you have small message queues, but not just one like API gateway, multiple message queues, right? Multiple message queues. And these are more suitable for asynchronous communication because these queues can keep the messages until this one is ready or until the response comes. This one is ready for the response. So therefore, this is more for asynchronous communication. Whereas API gateways are more suitable for synchronous communication because API gateway usually they don't have the message queues. So just call it and get the response and give it to the relevant client or relevant other service. So point-to-point style, API gateway style, more suitable for synchronous communication. But for asynchronous communication, we need sort of a message a broker. Broker is like an agent, so that it can keep the message until the other service is ready and keep the response until the caller is ready. Right. So those are three approaches. Okay. Message broker, API gateway, point to point. Right. So then the data management. This is integration or inter-service communication. Remember, when we have a module, it's not only process data, it's store data. Store, retrieve, update. Okay. So how the data is managed in monolithic applications. Obviously, monolithic means all your functionalities are in one big chunk. So then obviously you can have centralized database. Your database is called by your application, like in our applications like JDBC. At any time, whether it's payment functionality or order functionality or customer functionality, they just call the database. And you have central database like normalized tables. Okay. So that is the old approach, right? Monolithic application, centralized database. But when it comes to microservices, each microservice has its own database. That is why it's independent. You can see it's 100% independent, other than microservice calling another microservice. No internal connection, right? So each microservice has its own database. And this microservice cannot directly access this database or this database. But you can call the other microservice and that microservice can access its database. Okay. So that is different from this. For example, remember in semester 4, we discussed about EJBs. You can have different EJBs, but all these EJBs, like session beans, entity beans, they all refer to the same database. But here, each microservice has its own database, independent database. So that is how data is handled in microservices. It's not centralized, it is decentralized. Right? You can see multiple databases. So these are important for scalability. When you have thousands and millions of users, each and every user accessing the same database is not practical. But here, workload is distributed. And these are sort of private database to the microservice. That is why one microservice can't directly access another microservices database. No, if you want to access data, you call the microservice. Because microservice can access its own database. Right. So these are some, now you learn more and more features about microservices, right? So each microservice has its own database. Each microservice is independent, lightweight. Microservices communicate with each other using well-defined concepts like uh, point-to-point, API gateways, using message brokers. Right. Decentralized governance, another concept in service-oriented architecture and especially microservices. So you know what is governance? Governance means controlling. So in microservices, the idea is decentralized governance. So we want to get rid of central controlling points, right? So the governance or the control is decentralized. You can see these are decentralized. Microservice can call another microservice, but there's no central governance. So that is another feature of microservices, decentralized governance. Right? During designing, development, these are very highly independent components. No dependencies other than one microservice can communicate with the other microservice. Okay. Design time governance, right? Runtime governance at all levels, it's decentralized. No central control. Okay. Right. So then how do we identify or find out these microservices? Whether a particular microservice is available or not? So we need something like a directory where one microservice can check whether availability of another microservice before calling. Okay. Right. So we have two concepts related to that. That is service registry, service discovery. So service registry we discuss even in semester 4. We can have a registry of web services so that we can get what services are available and then how to call it. So same concept, but this is for the microservices. All the microservice instances and their locations. Basically, it's not the microservice, right? But what are the microservices available and the location, like a URL. Then service discovery is find the available microservices and their location. Obviously, the other microservices or when a microservice want to get some service of another microservice, it needs to check the service registry for and discover it. That is the idea. Okay. So the service discovery can be done in two different ways. What are those two different ways? Client side discovery, server side discovery. Client side discovery, server side discovery. So that discovery means identifying or locating microservices. So in client side discovery, okay, client find these registries and their locations. Client. Once it find it, it can do the call. It can do the call. So then each microservice must publish their presence and how to access them to the service registry. And the client discover microservices in the service registry and they get the location and how to call it. So then the client can directly call it. Of course, while client can directly call a microservice, then maybe another microservice at the same time. Microservice can call another microservice as well. Don't forget about that. Right. So that is client side discovery. Okay. So client side discovery is more related when client is calling different microservices. But when one microservice want to connect to call another microservice, so then microservices are in the server side So how does one microservice identify and locate another microservice? That is server-side uh, discovery, not client-side. Okay, not client-side. So you can see service registry call these things. That is called server-side discovery. Okay. Right. So then the deployment. So remember each microservice is independent. Right. They have their own database. Right. These microservices can be using different microservices use different technologies. One is .NET, another one is Python, another one is Java. So that means we can independently deploy and undeploy microservices. So if you have 10 microservices, even you can have those 10 microservices in 10 machines or 10 clusters because each microservice has its own database and so on. So that is good for scalability. Scalability. And also because they are so independent, failure of one microservice may not affect any of the other services. Of course, if there can be some dependencies, but in general, these are heavily independent. Right. So therefore, when we deploy microservices, there are technologies because these microservices are independent. Right. So one such technology or the most popular technology for deploying microservices is Docker technology. Docker. So Docker is a mechanism to package and deploy a microservice or microservices. Right? Docker is a package and deployment of microservices can be done using Docker technology. So that means you can deploy a microservice to the Docker container, or you can deploy it as a Docker container image. And each microservice can be a container. If you have three microservices, these three microservices can be three containers, independent containers. And these microservices can be independently built, deploy, start, stop, right, upgrade, and so on. Okay. So remember, you have learned about virtual machines from semester one, right? So remember from semester one, of course, we discuss it in semester uh, four also. Sorry, semester uh, five, system administration. We use a virtual machine to run Ubuntu or Linux. So there's a big difference between, or not a very big difference, but the very critical difference between virtual machine and container, VM and container. So remember in my laptop also I have a virtual machine in Oracle box. Okay. I can start my Ubuntu, right? So that is how we practice Linux in our from semester one onwards, right? So then inside my machine, I run a virtual machine, not one, maybe two, three, four, five. Of course, if you have a lot of resources. So these virtualization or virtual machines are one of the key concepts in cloud computing, right? Cloud computing. So you get access to a virtual machine. So what is the basic architecture of virtual machines or virtualization? On top of the OS, of course, there are different ways of doing virtualization. That also we discussed in semester 5, right? Under system and network administration. Uh, right. One approach is you have your host OS, right? You have your host OS or the kernel of the OS. Then on top of the OS, we have the virtualization software, hypervisor, like Oracle VirtualBox. This is host OS. Then hypervisor. Then on top of the hypervisor, you can have any number of virtual machines as long as you have the resources. Okay. Right. In my case, my hypervisor is Oracle Box, Oracle VirtualBox. And on that, I have only installed, set up one virtual machine. I can have another virtual machine, right? I can add more and more virtual machines and even start all these virtual machines or run these machines parallelly. If you have very large amount of memory and very good processing power. Otherwise, maybe just one or two you can start and run. Otherwise, it will be everything is slow. Okay. Let me switch off my Linux machine. Right, so that is called what? Virtualization or virtual machines. So look at this diagram is super, super important. Okay. Right. So this is our, let's first look at the virtual machine because that is something we have discussed few times. Right? So you have the hardware and guest hardware and host OS. मी वचन हरी वैसे करता है host guest. So this infrastructure means your hardware and host OS. In my case, my host OS is Windows. My guest OS is Linux, Ubuntu. Right. So in on top of your hardware and host OS, you install hypervisor. Hypervisor is just another program, software. In my case, my hypervisor software is Oracle VirtualBox. On top of the Oracle VirtualBox of my hypervisor, I can install OSs and applications can be installed, configured. Not one virtual machine, many virtual machines. Okay, so that is called virtualization. So then what is the difference in between the virtualization and use of Docker? Right? Docker is not really a virtualization. It's slightly different concept, slightly different. And here, again, you need the infrastructure or the hardware. And on top of that, you have the host OS. Here also actually on top of the host OS, you have the hypervisor. For some reason, it's not displayed. And infrastructure means host OS plus hardware. Here, hardware and host OS, they have separated. Right? But anyway, if you want, you can take it the same. So then on top of host OS, you have Docker. And on top of Docker, you can have any number of containers. This is different. First of all, you can see here you have the guest OSs. Here you don't have guest OS, just the host OS. Here also you have the host OS before the hypervisor actually. But here no guest OS. On top of host OS, you install Docker and then you install your containers. So containers are lightweight than virtual machine because every virtual machine has its own OS. But here, just one host OS and many Docker instances. And in Docker instance, what we have is an application. It's not a virtual machine, it's an application. Maybe a particular microservice. Right. So this is the approach we used in modern microservice deployment. Microservice deployment. Okay. So what is the most popular deployment environment? Docker. Advantage is it's lightweight than use of virtual machines. Because here you start with OS, but here you deploy your microservice or any other component as a Docker container. And again, you can stop your Docker containers or specific container. Okay. And this is the popular approach right now. Use of containers rather than use of virtual machines. Right. So that is called what? Docker software. Docker. So you can do a Google search and go to Docker and even download and install. Actually, we are going to download and install right after discussing the past papers if we have time today. Otherwise, next class. Right. Go to docker.com. You can install your Docker, download and install. So then on top of Docker, you can deploy your components. Okay. Deploy your components. Right. So that is called Docker. So then we have another software called Kubernetes. Right. Kubernetes. So Kubernetes is not Docker. Kubernetes is another software. Right. For example, if you search, this is Docker site, you can download Docker software from here. Later, I will explain how to download and use it. Docker desktop and so on. Right. This is a different software called Kubernetes. Right. Kubernetes is an open source platform designed to automate the deployment, scaling, and management of containerized applications. In our case, what is our container? Docker. But Kubernetes is not Docker. Right? Kubernetes is to orchestrate the containers like a musician, right? Orchestrate the containers because each container has a service or component or microservice. Okay. So Kubernetes gives additional fun features to make more and more scalable, reliable applications, deployment, right? So therefore, we can use Kubernetes on top of Docker or Kubernetes and Docker together to get a better control and so on. Okay. So very simple. It's a container orchestration software like Kubernetes. Okay. So we are going to install Docker, install Kubernetes and use it right later. So therefore you may not understand this 100%. By the way, this is a huge area, right? And remember, it's not all software engineers we need. Sometimes we need system engineers, deploy engineers, cloud engineers. Basically, what they are working with is mostly Docker, Kubernetes, and of course, sometimes raw server, Linux environment, and so on. Okay. So if you go to top jobs, හැබැයි ඉතින් මේ ගාන ටික එකගෙන මදි දැන් ඔයාලට starting point එකක් මම දෙන්නේ. So let's see whether there are any job postings for system engineers, deployment engineers. Still no. About 2 years ago or even 1 year ago, most of these job postings were software engineers. Now you can see less and less software engineers, more and more AI engineers, project managers. Okay, so you can see a lot of project management internships. I'm looking for some system engineers. You can see intern AI engineer. Or you can see DevOps engineer, DevOps engineers. Let's see what are the expectations. Right, cloud infrastructure architecture, secure deployment practices, third-party system integrations, and so on. Right. So basically, Kubernetes. They have not specifically named the technology, but those are the technologies involved. Okay. I'm just looking for one more. Right. System support engineer. I don't think that is very technical job. Yeah. So that is not a very technical. So this is also integration developer, but I don't know whether it's related to this area. Yeah, bit of integration. Research is disabled here. Ah, no. I think we look at this previously. Yeah, this is more application level. Okay, JBoss and so on. Apache. Right. So, so therefore, now you must understand that we are going to install these things later. Docker is a container, lightweight container as alternative for virtual machines. Kubernetes is a software that you can use to orchestrate these container management. Okay, container orchestration. Right. So then, how do we deploy microservices? You can install or deploy a microservice in a Docker instance. So then that Docker instance can be deployed as a separate, independent process in any server that support or any machine that support Docker or that has Docker installed. Okay. So we can deploy and it's scalable because you can deploy the same microservice in multiple Docker containers. Scalable. You can see Docker container. This Docker container has accounting microservice. Uh, in another Docker container, we have the inventory microservice. Another Docker container, you have the shipping microservice. Another Docker container, you have the store microservice. Maybe these two are in the same machine. These two are in the same machine. Or even these four can be in four different machines. Remember, one machine can have multiple Docker instances. Right? Just like one machine can have multiple virtual machines. But then, good news is Docker instances need less resources, whereas virtual machines need more resources because if you have five virtual machines, it's five OSs. But when you have five Docker instances, it's one OS. Okay, one OS. But like five different applications, those are the Docker instances. If you have five Docker instances, so it needs less resources, unlike multiple virtual machines. Right, security aspects. So in monolithic applications, your security is also built into that application. Remember, everything is in one chunk. Not only the functionalities, the security is also in that component. Okay. Or you have a separate component, but you deploy together. But in microservices, the security is more challenging. Why? When everything is in the same place, security is easier. Security is easier because everything is in one place. You can have central security, but when you have independent microservices deployed and running in different Docker instances of the same machine or different machines, now maybe you call this microservice call this and that, and this call that, and so on. It can be very complicated because each microservice need to take care of its security. If there's a loophole in one microservice, it can really compromise your application. Right? So therefore, you need some specialized security mechanisms for microservices because it's more challenging, demanding. So there are some standards like 0 auth 2 open ID connect. You need to remember these words because examiners have already asked about this. So technologies that contribute to the security in microservices because it's more challenging. What are those technologies? 0 auth 2 open ID connect. So there's a difference between 0 auth 2 and open ID connect, right? So in 0 auth 2, idea is there's something called authorization server, right? Authorization server. And from authorization server, client can get a token, which is known as access token. And this access token has no information about the user. It just give you the access, right? It's like a pass. If a particular call has the access token, it is allowed. But the access token has no information about the identity of the caller. Okay, so that is the idea behind OAuth 2.0. Okay, in a way, this is most privacy is preserved because no user details are sent with the request. Okay, so second approach is Open ID Connect. This is OAuth 2. In Open ID Connect, again, there's an authorization server. But that authorization server will send or provide not only the authorization token, some details about the user, username, maybe email address, and so on. Okay. So therefore, this is in a way little bit insecure and little bit compromising your privacy because this token sends some limited amount of data about the user. Okay. So therefore, not safe to use it outside the internal networks. Okay. Because this token has some details about the user. But anyway, those are the two approaches. Okay, two approaches. Sometimes you can use both together. Okay, both together. So you can see this is the client. A client called the authorization server, and authorization server send the authorization token, right? So that your mobile client can call REST web services or microservices. Because you already you have got the here you verify your username and password and so on, and you get the token. Right? You can give that token to get the access. Okay. So then what about the transaction handling when we use microservices? Remember we discussed about transaction handling in databases. That is monolithic. Everything is in one database. But now what we discuss is we have different microservices with their own database tables. Sometimes independent database. Now transaction handling is really complicated. If it is your central database, usually that transaction handling is done by DBMS. You just start transaction, end transaction. If there's some failure, your DBMS will roll back all the partial operations. So therefore, we had less work to do when it comes to standalone or monolithic applications, when it comes to database handling. But in microservices, because these are independent and they have their own databases, transaction handling is very complex because there's nothing called rollback, automatic rollback. For example, your client call this microservice, and this microservice has updated some data. Then you, as part of the processing, now you call this microservice. And already the data has been modified. But now you got an error or you get an exception. So then the client need to roll back this transaction or this SQL operation because this failed. So remember, transaction must be success as a whole or fail as a whole. But unfortunately, now transaction is not running in a single database. Transaction is running in multiple databases. So therefore, rather than handling transaction, that is rollback commit, in microservices, what we do is we do this and commit it. Then you call the other one and say we got an error or some exceptional situation where we can't do that. Now there's nothing called automatic transaction handling because these are two different databases. So then you need to do a reverse transaction. So that is one of the most popular approach because it's very simple. Say this is done, updated, then this got exception. Now the client need to, or the orchestrator or whatever need to send a opposite or reverse transaction step to this one because this failed. Okay. And if all success, when it is success, your client will send commit flags so that all of these machines have the committed values. Okay. Right. So the idea is go for transaction less coordination. Transaction less means rather than we handle it as database level transactions, we can do a reverse calls. Okay. You call it compensating operation. Compensating operation means reverse operation. If you have added 1,000 and this failed, then you need to reverse it, subtract 1,000. If you have debit 1,000, then you need to credit 1,000 because that is your rollback. But now you don't call it rollback. Your rollback happens in database level. Single database or multiple database. Remember we discussed about distributed databases. But this is a different story, different approach. Reverse transaction. Right. So other thing is when we use microservices, remember it's more reliable, scalable, because you can have the same microservice deployed in multiple machines. If one server is down, maybe we can redirect to the another up and running server. So therefore, when we use microservices in a proper deployment settings like multiple clusters and so on, it can be very reliable. Okay. Right. So we already discussed about orchestrating microservices, right? So one approach is use of gateway. So the gateway orchestrate to call the microservices in the correct logical order. Right. One such approach is orchestrate using the gateway. But this is not the most recommended approach because this, especially if this gateway is in the client side, that is unnecessary. You take the business logic or the control to the client. Okay. So you can see new business functionality is embedded into gateway that violates the microservices architectural principle. Okay. So this is another concept related to microservices. We can look at the microservice and its implementation and deployment as using inner architecture and outer architecture. So these are the clients. So you can have the outer architecture, inner architecture. So inner architecture is the one that really concerned about deploying these microservices on Dockers, not virtual machines, Dockers. So then you have other control mechanisms, security mechanisms, and so on. And can call microservices through this. And so usually we call this inner architecture, the internal things, outer architecture, basically the communication or the integration parts with client. Right. So in modern business organizations or any organizations, we heavily use microservices and proper integration, API management, and so on. Right. So remember, microservices is a modern approach. Right. Monolithics and variation of monolithic called coarse grain component based software like web services. So RESTful API, REST, those are not microservices. Now the trend is try to migrate those SOA web services or any other monolithic applications into microservices as much as possible. But it is not always possible because there are some mission critical, very business critical applications like banking applications where we can't easily upgrade it into microservice based architectures. Sometimes there are, of course, sometimes there's a cost because you need developers to develop these things new way. Okay. So therefore, some web services or components will remain for another 5, 10 years. But more and more we will move on to microservices, right? Fine grained microservices. Okay. Right. So then we have some past papers. So this paper is a 1 hour paper. So therefore you get only 20 MCQs. In a way it's good, in a way it's very risky. Because if you mess up few questions, right, all of a sudden you fail, right? Right. So, and you can see multiple answers are possible, so that make it even more challenging. It's not just one answer, right? Multiple answers with negative marks. Right. So first 5 questions are related to what we discussed today. Right. Question number 1. What is a key characteristic of monolithic architecture? Right. So there is a traditional architecture where everything is developed as one big chunk monster, including the database. Okay. Or coarse grain components still deployed together and so on. Right. Independent deployment of services. No. That is microservices. That is microservices. So let me use other pen. So that is wrong. That is not related to monolithic. Fine grain services. Yes, remember fine grain. SOA is coarse grain. Um, so in this is sorry. This is monolithic architecture, right? In monolithic architecture, we don't have fine grain. Fine grain is microservices. Sorry, this is wrong. All functionalities in a single application. Yes, that is what is a monolithic. Mono means one. Correct. Easy to scale. No, it's not easy to scale. Easy to scale microservices when you break it. Scale means when we have more and more users, we can support more and more users. So remember microservices, you can have multiple instances, same service, right? But not monolithic. Decentralized government. No, monolithic means everything is centralized. So the answer must be C. Yes, C. Second one, which characteristics best define microservices architecture? If you have any questions, you need to ask, okay? And now this question talk about microservices. Independent deployments. Yes, microservices, small and independent. Fine grain. Yes, microservices are fine grain. Like small pebbles, large number of. Because each microservice concentrate on one functionality. Centralized government, no, because microservices are distributed. Services run in their own processes. Yes, each service is own process, right? Own process, not tightly coupled. Not shared databases. Remember, microservice can have its own database, each microservice. So we'll go for A, B, and D. Yes, A, B, and D. What is asynchronous messaging protocols used in microservices? Synchronous, not asynchronous. Synchronous means you call and wait. Call and wait for the response. So obviously rest and thrift. So remember that those are mentioned in your note. All these questions are pretty much, over 90% of these questions are from your slides. Right? A and B. Yes, A and B. Fourth one. What are the styles of inter-service communication in microservices? Remember we discussed three styles. One is, yes, message broker, point-to-point, API gateways. ESBs are used in not microservices, rather web services, right? Web services. Shared memory is for monolithic. Shared memory means you use the same memory of the machine. Remember centralized ESB, it says centralized ESB. I don't know whether examiner take it, but definitely centralized ESB is in between, but not the three key microservice communication patterns. Okay, so therefore I'll go for A, D, and E. At A, D, and E. So these are straight from your slides. Question 5. Which aspects are typically included in microservice governance? That is controlling microservices. Remember, they are highly distributed. Okay. No centralized design time governance. Correct, right? The microservices is not centralized design time control. It's distributed, decentralized. Sorry, this is correct, right? No, it says no centralized design time governance. Yes, correct. Because it says no. Services make their own design decisions. Yes, microservices are independent. We can design them independently. Runtime governance at API gateways. Runtime governance at API gateways. Yes, we can call them API, but is it runtime governance? But anyway, API gateway is one approach of, remember, one approach of integration. But this doesn't say integration, it says runtime governance, right? Let's keep it open. Centralized control over all services. No. Microservices are not centralized. Shared service logic. No. Logic is independent, not shared. Okay. Right. So AB looks okay, but what about C? Runtime governance by API gateways. Shall we take it? Because here we have API gateway as a communication mechanism. Okay, I'll take C. I'm not very sure. I'll go for ABC. Yes, ABC. All three. Okay, all three. Right. Because this is inter service communication pattern, right? So therefore we'll take that also, right? ABC. Right. So those are the 2024 questions. Okay. Right. So now let's look at 2023. Again, I think five questions. And again, multiple answers are possible. Right. What are the key characteristics of monolithic architecture? Independent deployment of services. No, that is for microservices. Fine-grained services. That is for microservices. All functionalities in single application. Yes. Easy to scale horizontally. No. Decentralized governance. No. Answer is C. Ah, sorry. I'm again looking at the same paper. Sorry. So let me open 2023 paper. And I'm looking at the same question actually. Okay. Right. So let's look at the 2023. Earlier one is 2024. Sorry. Right. When would it be advantageous to use monolithic architecture over a microservice architecture? So remember, monolithic is outdated, but still there can be situations, right? For example, very simple application with very few functionalities. Right? For simplicity, yes. Right. When building a small, simple application, exactly. Yes, still we can use monolithic architecture. When requiring high fault isolation between different parts of the application, if you want to isolate faults, you can't develop everything as single unit, right? So therefore, no. If you want to isolate faults, you need to isolate functionalities as well. That is microservices. When the application is expected to have rapid and frequent changes in specific parts, right? Monolithic architecture is very difficult to modify. Okay, change. So therefore, if you need rapid and frequent changes, I don't recommend monolithic. When the development team is small and the project time is tight, yes, maybe if the development team is small and we have very tight project time, right? So then we can't go for the best solutions. Rather, we can come up with a quick and dirty solution that is monolithic. I'll say yes. When there's a need full of straightforward, unified development and deployment process. So when there is a need for straightforward, unified development and deployment process. Yes, right. So then we can go for monolithic because they don't like distributed approach. So then I will go for A, D, and E. A, D, and E. Yes, A, D, and E. Second one, what are the characteristics of a monolithic architecture? Single code base, yes. Easy to scale horizontally, no. Tight coupling between component, yes. Actually, either there's nothing called component, or if you have component like SOA, like traditional web services, these are coupled through database and so on. Centralized logging and monitoring. Yes, you mean monolithic, it's centralized logging. Independent deployment of individual components. No. So the answer must be A, C, and D. Yes, A, C, D. Third part. What are the typical challenges of implementing a microservice architecture? Right, like security, uh, complication in communication, transaction handling. Okay, right. So let's read one by one. It is easier to implement security policies uniformly across the application. No, difficult because now these are in different machines, different servers. A lot of communication in networks. No, not easier to implement. Increase complexity in managing inter-service communication. Yes, that is why we need some well-defined process patterns. Simplify debugging and testing. No, right? These are remote now. Part is here, then it calls the another machine. Difficult to debug and testing because everything is in one place. Easy to debug, same code base. Potential for data consistency issues across the services. Yes, data consistency issues because these are independent databases, right? Not like normalized tables. So therefore, there can be actually there can be data inconsistencies. So data inconsistency means data consistency issues. Yes. Need for robust DevOps practices and tools. Yes, you need robust DevOps practices and tools because these are independent services. So you need tools like Kubernetes, Docker, right? So that you can automate your deployments, orchestration, and so on. Right? I'll go for everything other than C. Sorry, not other BDE, BDE. Yes, BDE. Which of the following statement about Docker containers are correct? Docker containers. Remember, Docker containers are lightweight compared to virtual machines because each virtual machine has its own guest OS, but here only the host OS. Docker containers share the same OS. So therefore, these are lightweight. Lightweight means faster, simpler, easy to handle. Containers provide lightweight isolation compared to virtual machines. Yes. Containers can be easily versioned and rolled back. Yes. We will learn about those things in our next practical session. So you can say it's a version 1, version 2. Say you do some modification. So you can keep multiple versions at any time. If you want older version, you can get it. Okay. So these uh, instances you can publish. Yes. Containers share the host system's kernel. Yes. So one host system. Kernel is the core of the OS. So that is shared for each and every container. That is a virtual box that we don't share. Each virtual box has its own OS. So this is correct. Remember host, not guest. Actually, there's nothing called guest OS in containers. You have a host and guest OSs in virtual machines. Each container includes its own operating system kernel. No, right? Containers don't need own OSs. That is virtual machines. Containers are inherently secure and do not require additional security mechanisms. So that is a debatable answer, right? Of course, containers can have certain level of security, but I don't know whether we don't require additional security. Usually we need additional security for each and every. Anyway, that's a little bit fuzzy question. So therefore, I'll keep it. I will not mark it as correct. I will go for ABC. Yes, ABC only. Fifth one. Which of the following is a components of Kubernetes architecture? Right. Since still we have not discussed about Kubernetes technical stuff. Right. I just mentioned that Kubernetes is component orchestration software. So therefore, we'll skip this question for the time being because after doing the practical session, you will understand these concepts like pods, nodes, services, and so on. Okay. Anyway, the answer is uh, other than pods, nodes, services, config maps, and so on. Okay. Because Kubernetes don't see it as a container. Container is a concept for the Docker. Okay. Don't worry, we will look at these things in the practical session. Okay. Right. So that's it for the 2023. Let's look at the 2022 paper as well. So then past papers are done. Only thing is we need to do a bit of a practical thing so that you get better confidence about these concepts as well as it's good for your career. Okay. Right. 2022. Right. Question number. Again, multiple answers are possible. A monolithic architecture is the traditional model. Okay, I will keep these five questions for you, right? Because otherwise you run out of questions for you to do, right? So we will do these five questions at the beginning of the Friday session, sorry, Thursday session, and then do the practical stuff. Okay, practical stuff, and then possibly we can finish it in 1 hour practical stuff and this discussion then for 1 or 1.5 hour. So then we can do another topic, another section in another topic as well. Okay. Right. So make sure you attempt these five questions and see whether you can get 5 out of 5. That means if there are three answers, you must get all three correct. Otherwise, you won't get the full marks. Okay. Right. So I just keep those five questions for you. But we will discuss that as the first thing in Thursday class and then the practical session. Make now the very good thing if you can, what you can do is because now you must try to do self studies. I have shared you two practical sheets. Right. First, go through the windows. You can see practical Linux, practical Windows. First, see whether you can install Docker and Kubernetes and do these practicals. And I have given you the web links as well. Okay, web links as well. Use these, go to these videos, uh, right? These are about some 10 minutes, 20 minutes, few videos I have given. Okay, and see whether you can complete this practical by yourself. Or, and of course, additionally, you can also search, right, Kubernetes tutorial, simple Docker tutorial, Docker Hello World tutorial. And if there are issues, how to install Docker, how to install Kubernetes, because you are in the final year, right? So now you must start becoming more and more independent. If you go for job, of course, you are alone, right? Right. Of course, there's a team members, but you can't always rely on them. So therefore, start doing your independent studies. Right, we stop at this point. So make sure you go through these two practicals and do it by yourself or any other practicals as well. First do it in Windows, then do it in the Linux machine. Right, Linux machine, both. Okay. So that will give you fairly good understanding about what is this Docker, what is this Kubernetes, right? What is a microservice, and so on. Okay. Because now you have the theoretical background, not the practical touch. Practical touch is when you do this thing by yourself, not by me. Right. We stop at this point, right? Thank you.